Good evening from Emerald Hill Skies. My name is Doug. We're here on the outskirts of Louisville, Kentucky, and we're happy you're here with us for another Emerald Hill Skies live stream. Tonight we're going to go on a chase to try to find some cosmic challenges. And this book by Phil Harrington is turning out to be really a good gold mine. It's organized by categories: naked eye challenges, binocular challenges, small scope challenges, medium scope challenges, large scope challenges, and monster scope challenges. Monster scope challenges are supposed to be tackled by those with a 15-inch and larger scope. But we're going to have to make kind of a slightly edited version of his table of contents, because it's turning out to be that you can also do monster scope challenges if you have an 11-inch scope with electronically assisted astronomy. And I hadn't thought about this before, honestly. But you guys might know that we are using a RASA 11. It sits on top of an iOptron CEM70G mount on top of an adjustable height pier from Pier-Tech. And it's out there in this observatory that is a Pier-Tech Tele-Station 2 observatory. And we use a primary camera, the ZWO ASI2600MC Pro. You can see it there mounted on the glass corrector plate of the RASA. So it looks like it's right in the way, doesn't it? It's got, a lot of, like 40% of the front end of that corrector plate. But it turns out that the designers of the Celestron RASA 11 telescope kind of knew what they were doing, because that blockage seems not to really hurt what we're seeing very much. Maybe because it's right there in the center of the glass, I don't know. There's a little equipment plate that rides on top of the scope, kind of like an outrigger, and on that equipment plate we have mounted a ZWO ASI2600MC monochrome camera. And that gives us these amazing sky views, so we can kind of keep, connected to the sky. And you can see a lot of those amazing points of light, along with, in the upper right-hand corner of that view, you can see that giant 50% moon. It's 50% or so. And at the base of the scope, there's this little thing we call a rig rack. It's got all the voltage converters, the 110 distribution box and the voltage converter there, the mean well kit that we built. It's got the distribution that's sent out to each particular piece of equipment, and it also has, at the very far right there, the Icron box that converts the data over to fiber optic cable signals, sends it across fiber optic cable about 200 feet inside of the building where I'm seated. And then on my desk here I have the mate of that box, which kind of interprets it back again, translates it back into data, and feeds it into my Lenovo ThinkPad laptop that I'm using, so that we can actually see some sense out of it. The telescope we're using then, this is a live view on the left. That's that RASA 11, and it looks like it's a daytime snapshot, doesn't it? It looks like we might have captured that today during the afternoon. But that's because we're using a kind of a night vision security camera that's completely seeing in the dark. There's little or no illumination there. There's one tiny LED back there on the back wall of the observatory. You might see it emitting some orangish light, and that's just the pilot light for the motor that opens up the roof, the roll-off roof of the observatory. You can see how the roof rolls off. So that motor is mounted on the back, and that's the only light in the observatory. The other light is the moon that you see up there in the upper right of this SkyCam view. So On the screen, you'll kind of get used to it. You'll see the scope there. And tonight, we're actually running the mic on that security camera so that maybe you'll hear every once in a while some kind of outdoor sound. Maybe it'll be a hyena, or no, probably not a hyena. Maybe a hyena. Maybe it'll be an airplane flying overhead, or we hope the slewing sound of the telescope. We hope you can hear it over the top of this music we're playing in the background. So these are live views. It's a live view of the SkyCam, a live view of the scope, and a live view of me. And here on the screen, you can see we also have a live view of the Stellarium planetarium software that we use. And we're looking at a patch of the sky here that has a nice tight collection of galaxies. Let's back off and see where we are. We're kind of looking up just to the right of the meridian, aren't we? This red line, or green line, I guess that is. This green line is the meridian. So that's the north. So it would be east. No, that would be north-northeast, right? We're looking north-northeast, just right above Cassiopeia. And you can see this little dark patch of the sky. It doesn't look like there's much there, but in that sky is this nice collection of galaxies that we can call the NGC 51 group. And in Phil Harrington's book, he actually provides a little map of this in his list, the Cosmic Challenge number 177 for monster scopes. So we're gonna glance through these in just a second with a live view. But before we do that, we're gonna go here to the screen and make sure we have audio. I hope so. Let's just listen. Yeah, we have audio there. Tiffany, it's good to see you and your Shih Tzu. You're very kind. Thank you for your time, for being on this evening. And appreciate you being on from California, all the way out there out west. Ricky, good to have you aboard. And any others who are there watching, if you'd like to say where you're watching from, you're kind of observing real time with us. So this has been the it's Stellarium. It's a free software that you can download. Just search for it online, and you can download it and install it and look at the planetarium view with us. And then now we're going to go to the actual screen. To the actual telescope view. And we've been collecting these images now for 11 minutes. And you can see we've got the special tool up here that lets us see deep sky image annotation. And it actually labels things and overlays them over the top of the real-time view. So you're actually looking now through our telescope with me. You're seeing this real-time if you're watching live. If you're watching on the recording, by the way, welcome. Glad to have you here. And we're looking at these at the same time. I love this. And I'm going to just zoom in a little more here. Now we're a little past our optical zoom. We're at 100 and actually 272%. So this is a very, 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 very small part of the sky. As you can see, 270%. Now we're using what you might call digital zoom on our ZWO ASI2600. Right away you can spot a difference between these galaxies and their light, can't you? As compared to the white light from the stars. And that's real green light. You can really tell they're not only oblong splotches, but they're also a different color than the stars. So let's get rid of this. Well, first let's make a note. So it's going to be 51. This is NGC 51, 49, 48, and then IC 1536, 1535, 1534. So we're kind of looking at them in order. 51, 49, 48. Let's go over to our observing software. We use Deep Sky Planner, and first thing I need to do is create an observing session for tonight in the session browser. So we'll look here at our last observing session, which was September 30th, and it was session 126. So then we'll make a new session, and this will be session 127, and it started on the 22nd at 10:40, and we're going to go through the 23rd, and we'll just guess that we'll be gone by 1:40, long gone. And we'll say the moon was, what is the moon tonight, at 48% or so? Is that what it is? And then we'll save that. So now we have the session configured. Now we'll go to the actual add an observation. And we're adding an observation for NGC 51. So we'll come right here to 51 and say add an observation. Oh, Ricky, sorry about the kitten with the broken leg. Taking her to the vet. Stu from Tauranga, New Zealand. Good to have you aboard, Stu. All the usual suspects, huh, Stu? All right, so our first observation here is NGC 51 that we're going to log. Now let's take this 51, 49, 48, and then IC 1536, 1535, and 1534. So first, let's start with NGC 51. NGC 51, and this is a galaxy in Andromeda, yeah. And let's take the Deep Sky Image Annotation off. So now we're looking right here, and we don't see much more than a blob, but let's see what Harrington says. Of the dozens of galaxy groups scattered around the autumn sky, the 136 million light-year distant NGC 51 group is one of the more difficult bunches to spot. Although they are not listed among Paul Hickson's compact galaxy groups, the 6 galaxies here are ideally placed near the zenith in early October and November evenings for observers in mid-northern latitudes. Its high altitude carries the group far enough above any horizon-hugging interferences that might spoil some of our other challenges. And then you've got a table, and sure enough it says NGC 51 is magnitude 14, and it's 1.2 arc minutes by 0.9 arc minutes. Tells you how to locate it. Says a string of 3 NGC galaxies highlight the sextet. All were discovered in 1885 by American astronomer Lewis Swift through a 16-inch refractor. That would be a nice scope. The easternmost of the trio is the lenticular galaxy NGC 51. So it's lenticular. Most astronomers find this to be the brightest and easiest of the bunch to spot, although it can still be tricky at photographic magnitude 14.4. Slightly oval disk is punctuated by a brighter central core, making it possible to glimpse NGC 51 through 10-inch telescopes through superior sky conditions. Then it says, can you spot a second dimmer smudge 2 arc minutes to the west? And that would be this. That's NGC 49. Look for the small, slightly oval blur with a brighter stellar nucleus that becomes evident by using averted vision. We don't have to use averted vision with electronically-assisted astronomy. He says he needed an 18-inch reflector to see this. And here is NGC 48. It's a third faint fuzzy, and it's rated 14th. The larger apparent size causes its surface brightness to drop, hampering detection. It displays a faint stellar core surrounded by an even dimmer galactic halo that appears slightly elongated southwest-northeast through his 18-inch scope. So what's really beautiful about this is that you can get an 11-inch telescope and use EAA, Electronically-assisted Astronomy, and you can see that halo that represents the arms of NGC 48. And you can see that elliptical glow. So let's write down here for NGC 51, nice group, easily visible even with Bortle 6 skies and a 50% moon. Wild. Elliptical 14.4 mag, 1.2 arc minutes wide. I wonder what the distance is light year wise. See anything on that, Stu? Lenticular galaxy in the constellation Andromeda has a diameter of 90,000 light years, discovered on September 7th, 1885 by Lewis Swift. Supernova SN 2016 GXP, magnitude 18.6, was discovered in NGC 51 on October 5th, 2016. Cool. I don't see any supernovas tonight. However, there's a nice little star out there to the edge of it. We're going to put what Stu found here. It was 90,000 light years diameter. So roughly the same as the Milky Way, huh? Cool. Now that's 51. Let's add 49. Fainter still. A splotch. This one is apparently 1 arc minute wide, 14.7 magnitude. Boy, it just shows up easily there, doesn't it? So that tells us what EAA can do. Of course, we're at 20 minutes now. And then (48). Wow, we could make out the spiral structure of NGC 48. Stu says 250 million light years away. Along with its core. Wow, it looks barred from our view. It's a beautiful galaxy. Can you believe that we're looking at something that is 250 million light years away? The interesting thing is we're seeing it real time, and if it's not barred, then there's quite a good spiral ring structure there. We're looking at it sort of edge-on-ish. Ray, good to have you on from Arizona. This is a nice group. Now, over here on the right-hand side, then, you see a kind of an echo of 3 additional galaxies. This is IC 1536. The whole thing goes by the NGC 51 group, NGC 51 galaxy group, at least in Phil Harrington's book. This is makes a nice symmetry with the 3 NGC objects next door. Curtis Horn. Right, zoomed in. Yeah, the focus is off because we're at 231%. of our frame. This one is definitely spiral. This would be IC1535. We could definitely make out the spiral structure. Almost edge on. IC1535, and then up here is the last one, IC1534. We're at about 69 degrees above the horizon here, east, northeast, or I'm sorry, north-northeast. So this one is way up here. This one looks very interesting. It has a huge core, doesn't it? And just has a kind of halo around it. This is 1534. It's also 1 arc minute wide. This is more like 15 magnitude. Teeny tiny, but we can see the giant core and the halo around it looks elongated. But this galaxy looks different. What do you think, Stu? This is a little different, huh? This is 1534. Let's go see if we can find a Hubble view of IC1534. IC1534. No, nothing under the Wikipedia entry. Oh, maybe in a different language. Let's go ahead and go for image view. Ah, it's a lenticular. Boy, I don't see anything. IC1534 Hubble. Wonder why this Hubble Spies a Hidden Galaxy is coming up. That's not 1534. So that's just finding another Hubble shot because it can't find 1534. I don't see where anybody's ever taken a picture of this and put it on the web from any observatory anywhere in the world. But it is very interesting. Let's look at this. So that must be 1534. See how large the not much different than what we're seeing, huh? Sadly. Anyway, it's an interesting galaxy, isn't it? It has a super large core, and then the halo is more like it's a thicker halo. It's kind of like, I guess it could be sort of like Saturn when your rings are visible, right? Like if rings are at a 45-degree angle. Anyway, it's very cool, isn't it? Rings might be at a 45-degree angle because they're much thicker than the traditional spiral galaxy. Yeah, we're going to go with the fact that we think their rings are thicker. Yeah, Curtis asked, what group is this? And Stu answered, NGC 51 group. Not a very well-known one. All right, this is a great little group. I think what we ought to do is take a picture of this up close. So let's use this screenshot deal. Something like this. And we're going to go to Sharp Captures and call this NGC 51 group on 2023-1022. It has 29 minutes integration. While we've been observing these 6 objects, so about 5 minutes per object. That's not too bad, but we do need to move on, don't we? Ken Allen, good to have you aboard. All right, just to kind of put things in perspective, let's go back out to our native what would you call this? The entire field of view of our ZWO ASI2600MC Pro. And as you can see, these objects are right there in the middle. But I don't think that they would have stood out to us, would they? Well, I guess you can barely see, can't you, that they're a little bit fuzzier than a star. But look at this star. I mean, it's just burned in bright enough that we might not have noticed these unless we had known to look for them. But I guess when we know to look for them, they do stand out. Once again, looking in our planetarium software, you notice they don't have any artwork of these. They just have the little, you know, the little red discs that are pointing out that there is something there. I don't know if that's... No, that's a star. So no artwork of these at all. They're so exotic. By the way, here's Andromeda Galaxy. Should we go over and look at Andromeda Galaxy real quick while we're here? Just real fast. All right, let's save this picture also at full screen. Sorry about the bad weather, Tiffany in San Jose. Tonight we can see a picture of your dog and you. That's awesome. All right, so we're going to stop live stacking here and just turn it off. Maybe which one of these do I want to use? Prep for imaging only, maybe. No, that wasn't it. That wasn't the right one. Stop. Stop. Okay, there we go. Let's just manually stop live stacking. Change our exposure. Actually, that won't be a bad exposure. And let's go over here and let's get our that shouldn't be a bad setup. And let's go to current object slew. You can see just a slight slew there as it slides over to Andromeda. And Andromeda Galaxy is not on our observing list tonight, but it was so close that it seemed criminal not to just stop by it, right? So this is a planetarium software version, obviously with Hubble or something that's just really showing off all those dust trails. Isn't that beautiful? Now let's go to the live shot and do a reset here. And live stack here. M31. Clear the stack. Wow. Look at that. Isn't that just amazing? That's one frame of 20 seconds. Isn't that remarkable? Look, after just 20 seconds, we could see these dark dust lanes in the spiral arms. It's just such a beautiful sight, isn't it? So this would be Messier 31, wouldn't it? And then here, tighter, is this, I always get these mixed up, is this 32 and that's 110, or is it the other way around? Let's look. Yeah, that's 32, and this is 110. So this is 32 here, M32, and that's Messier 110, which, of their own right, Messier 32 is bigger than anything we're looking at the entire night. It's just a satellite galaxy of M31. So that's 4 frames, just 80 seconds. Look at these dust lanes way out here now we're starting to see. So that's like looking at some of the dark Barnard nebulae that we look at, see? Just dust that's blocking our way from seeing that part of the spiral arm. Now you're seeing that dust lane really come into detail now. See how you can see the different degrees of dust here. Super bright core, huh? Now you're starting to see some of these blue stars that are younger. all of these outlying arms. Isn't it funny that if God did make other worlds, and if God did choose to place people or some kind of beings on those other worlds, isn't it kind of a fun thought that maybe tonight there's somebody on a planet in the Andromeda Galaxy that has a RASA 11, and right now she or he has that RASA 11 trained on the Milky Way galaxy, doing a live stream perhaps this very night, talking about the beauty of the Milky Way galaxy. Wouldn't that be cool? And Ray also has Andromeda Galaxy queued up in his RASA 11. So we have twin things going on here. I Hate Clavin Lim is talking about, have we ever looked at Stephen's Quintet? It's a really low object, but it's one of his favorites. I have, as a matter of fact, Stephen's Quintet. Andromeda is 152,000 light years away and is approximately 2.5 million light years from, or 152,000 light years wide and 2.5 million light years away from Earth. By contrast, the last object, I think you found that it was, Stu, didn't you find that it was 250 million, or somewhere we read that it was 250 million light years away. So what would that be? 100 times closer. This is 100 times closer than the NGC 51 group. Once you get to this level, now we're seeing dust way out here at the edges. Look at this outlying, these outlying arms now, way out here. It's just beautiful, isn't it? Now you can start to see the way this dust is kind of taking on that dirty color compared to the greenish and yellowish of everything else. Just starting to look very dirty. "100 times closer and nearly twice as big," Stu says. Fu Man Yi says, "Greetings, Hill Sky. Always a beautiful sight with your streams. A little bittersweet, I could say, when we lose the astonishing feeling to look up the stars. Every night is a little darker in cities." Yep. Ken says, "Don't go out of the lane too far left." I Hate Clavin Lim says, "Dang, I missed it." Stu says, "Yeah, we did the Stephen's Quintet just a couple of sessions ago." You can go back and check it in one of the videos. Saludos Monterrey. Mario. Gracias por estar con nosotros, Mario. Es un privilegio. Well, this was off course. It was not on our plan, but we saw it in the planetarium software and just seemed like it was criminal not to stop by. Let's go ahead and save an image of this at just 6 minutes and 40 seconds, because it is quite an image to behold, isn't it? Even at under 7 minutes integration, it's just gorgeous. Okay, let's get back on track now. So we're going to say next target. And let's go back over to our target software. The next one is, I don't know why this is there. It's Alpha Andromeda. It says HIP Hipparchus 677. So let's go ahead and play along and go there. It's object number 10 in Phil Harrington's book. So slew to Hipparchus 677. It's at 68 degrees above the horizon. And I'm going to put here in the middle that it is Hipparchus 677. You notice we add the object name in SharpCap because that's what SharpCap grabs in order to create the name of the photographic file. So that's why we have to put it in to SharpCap. And I'm guessing this must be that single star. Now let's figure out why we're looking at a single star. Object number 10. I guess it's a naked eye challenge, right? So we're going back and forth between the different levels. And I see it's the great square of Pegasus. So he's basically saying, use Alpha Andromeda to find the great square of Pegasus. And it is one of the best known autumn constellations. Depicts a winged horse used by Pegasus to rescue Princess Andromeda. It's usually drawn upside down. And then he describes each star in the square because he's trying to find something to say to the folks that are observing with naked eye. So let's go to our SkyCam and let's see if we can get oriented here. Would this be the great square? Yes. And this is the star we're looking at. Alpha Andromedae. And then this would be Beta. And this is Alpha Pegasi or whatever. And then that is, what's the Greek letter that looks like Y? I can't believe I had 5 years of Greek, but I'm just having to ask that. Is it Gamma? Looks like a Y. Anyway, that's the great square of Pegasus. How about if we go over to our Tiffany, you're like the hostess of the room. I love this. Okay, so there's Alpha in the middle, and let's back off some, and let's look at this great square. So here's Alpha, that's Beta, and this is Alpha Pegasi, and this one is the one that has that Y character. So can you guys make out that Y? What is that in Greek? Algenib. How do you pronounce that Greek character? Anybody know? Alpha Andromedae is 97 light years from the sun. It's the brightest star in the constellation of Andromeda. Stu, you're giving me something to write in the observation, and otherwise I would have been completely without anything to say. Let's go back over to the live view. Oh my goodness, is that not bright or what? This is through the 2600. Alpha Andromedae is 97 light years from the sun and is the brightest star in Andromeda. Thanks, Stu. It appears to naked eye as a single star with overall apparent visual magnitude 2.06, although it's actually a binary system composed of two stars in very close orbit. Sure is bright. Tiffany says, Stu, you're a star. Actually, a binary. Forms the corner of the great square of Pegasus. So that's why we're here. Look at the halo it makes. Now here's an interesting artifact with the RASA. Let me zoom in on this. Can you see this little artifact here in this star halo? Guess what that artifact is seeing an echo of? Just guess. Sure enough, it's those two cables. So there on your screen, you can see the two cables that are feeding out from the camera out to the outside. And then here you see kind of the little artifact echoes of those cables. And they only show up in the bright star halos of stars like this that are so bright that it creates a kind of an echo of those cables. Isn't that funny? Some people go to a great length to try to hide those, and they've never actually bothered me, because we don't go and look at bright stars very often, do we, gang? This might be one of the first times, in fact. But it is easy to see. Look like little cat whiskers, don't they? Tiffany probably could point those out on her cat, I think. Kim says, almost need my sunglasses. Stu says, it's the brightest Mercury-manganese star known. Contains abnormally high levels of mercury. Doesn't sound very healthy. Well, we could be seeing these with our naked eye, and then the sky would look something more like this. And that's the star right here. That's the star we'd be viewing. So that's the Great Square of Pegasus. Now let's go back to our planetarium software and back off enough to see. So these are the four legs that are pointing upward. Now let's go back to the live view in the 178. So this star is part of this is the body of the horse. That's the leg. And then this leg goes out like this. This leg goes out like, let's see, like that. Is that right? Yeah. And then this is the head. Right here. Almach. And the Andromeda Galaxy is right here. So if you want to see how to find this naked eye, find the Great Square of Pegasus. Let me zoom in a little bit more. Find the Great Square of Pegasus, those four stars, really bright. Come up toward the head of the horse, and out here there are these three stars that point more or less to the Andromeda Galaxy. You can see it there as a smudge. In our ASI-178's field of view, you can see it looks like a smudge. It's pretty fun, isn't it? We're doing constellation hopping here. So this would be Cassiopeia, right? Cassiopeia? Whoa, what happened? There we are. Get our bearings. Pegasus. Yeah, there's Cassiopeia. I couldn't see it with all the labels here, but there's Cassiopeia. See the W? Or the McDonald's M double arches, whichever you want to see. Cassiopeia here. And then what? Triangulum, is it? See, here's the square. We don't see triangulum as well, do we? It's down below this. But we should see Perseus. Here's part of Perseus. And there's the moon, of course. All right, well, that should wrap up this viewing of this super bright star beacon. And let's head off. Why are we live stacking a star? Let's head off to next target. Kevin, good to have you aboard from Redlands. Ray has his cables at 90 degrees, which causes it to make it look more like a daub image. Shih Tzu eyelashes. There you go, Tiffany. All right, we're off to see NGC-1. Wow, the first object in the NGC list. NGC-1. Now, are you guys hearing the... boy, that didn't move very much. Are you guys seeing the... are you guys hearing much of the telescope? I bet you're not, because the music's probably too loud. I have it set so I don't have the music playing for me here, because the music competes through the mic and you hear it twice and it makes a dumb echo. See, oh, I don't hear the music. Oh, there it is. So you hear the music coming out of my speakers, see, and then it makes a real echoey. So I keep the music muted in my speakers, and it's just going straight to you, like over the audio line only, you know. So we're not broadcasting it here in my room with me. That way you don't hear the echo of it. So I can't really hear those those telescope sounds, but maybe in a minute, if we do a longer slew, I should turn off the music and then unmute the security cam microphone, and let's do that slew live so we see if we can hear it slew over the mic. That'll be interesting. I haven't ever tried that before. NGC-1. Let's show chart on that. NGC-1. Where is it? Oh, there it is. No artwork on this either. This is a star. Well, maybe that is NGC-1. That orange ball there might be NGC-1. And NGC-2 has no artwork. I suppose it's possible. Yeah, I think that's right. NGC-1. Interacting galaxy. You don't hear any music. NGC-1 is an intermediate spiral located approximately 250 million light years from the solar system. The constellation Pegasus was discovered on 30th September 1861 by Heinrich der Rest. Henrik der Rest. I don't know if that's German, maybe. Heinrich, der ist. I don't know how to say German. All right, let's go over and see a live view of this. Boy. Not much to this, is there? Wow, this is object 146. So this is back here in the large scope challenges. NGC 1 and 2. Apparently NGC 1 is magnitude 12.8 and NGC 2 is 14.1. They're only 1.8 and 1.2 arc seconds wide. Harrington writes, I'm always interested in seeing the first of anything, whether it's the opening day of a baseball season, the first robin of spring, the first snowflake of winter, or the first object in a particular deep sky catalog. In the case of the last of these, NGC 1 along with NGC 2 create our next challenge. When he assembled and published the New General Catalog in 1888, John L.E. Dreyer decided to organize the more than 7,800 entries in order of increasing right ascension beginning at 00 hours, and that's on the equatorial grid instead of the altazimuth grid. In epic 1860 coordinates upon which the original NGC was based, this tiny pair of galaxies came in first, with NGC 1's position listed at 00 hours, minutes, and 4 seconds. But in the ensuing years, Earth's precession, that slow circular 26,000-year wobbling, has shifted the celestial coordinate system underneath the stars. Today, in epic 2000 coordinates, no fewer than 30 NGC objects have lower right ascension values than NGC 1. We are not going to let that little fact spoil our fun, are we? Never, he says. NGC 1 and 2 still present formidable challenges for our telescopes. Together, these fire galaxies are located at 1.4 degrees south of Alpheratz, the star at the northeastern corner of the Great Square. He tells how to find them. NGC 1 is the brighter of the two. May actually be visible in telescopes as small as 6 inches under dark skies. He says his 10-inch uncovers a dim oval disk at just 2 arc minutes of an 11th magnitude star. So here must be the 11th magnitude star, or maybe this. And this is NGC 1, I'm assuming. Are we close enough to do deep sky image annotation? Yeah. So this is NGC 1 and that's NGC 2. They do look greenish again, don't they? Tiny. NGC 2 is slightly elongated. 3 times fainter, only shows us a faint uniform glow. They're not a true physical pair. NGC 2 is farther away. You can tell that by studying the red shifts of their spectra. What did you have? He has 190 million light years away. And NGC 2 is 329 million light years away. 190 and 329. $190 million light years away, and Stu said it was 140,000. Oh, you had a 215 million. 140,000 light years across, roughly the size of the Milky Way. So the Milky Way is actually 160. That's a little larger than I remembered. Does Emerald Hill Sky ever discover a star or something that is not recorded or taken a picture of? Boy, I don't think so. I don't think we've ever discovered a star. You know, oh my goodness, I'm so sorry. Stars are, through the Gaia survey, I think there are like 1.2 billion stars cataloged in the Gaia survey. So they go down to like 20th magnitude or something in the Gaia survey. Anyone know how to get the emoji off the chat screen? I don't see it. Where is the emoji, guys? I'm not seeing it in my chat. First object on the NGC list. And NGC2. Elongated, 3 times fainter. Ray says, don't forget to like the video. You're very kind, Ray. That does bump it up in the algorithm, they say. 100. Do we have anything on NGC2, Stu? 300 and... how far away? 329 million? 329 million light years away. Only 1.2 arc minutes. Only 1.2 arc minutes across. So we have our, what you would call the digital zoom pumped way up here. 225% of where we really should be with optical zoom. There's the limit of optical zoom. So that's what our pixels actually allow us to see. Anything beyond this, and we're actually cheating a little bit. So we're really here because it's NGC1. That's why we're here. Bottom right corner of my screen. You know what I'm going to do? I'm going to go look at the... I'm going to put you guys on the scope for a second. I'm going to go look at the stream in YouTube. Ah, I see. There's a heart there. I see what you mean. It looks like it's designed to let you put a heart there. So, oh, yeah, you can send hearts up like that. But it is like right in the way of... It is kind of in a weird place, isn't it? But I don't see any way to turn it off here either. Bummer, huh? Well, sorry about that. I'll have to look and see how to fix that. NGC2 is about 115,000 light years diameter, 3 to 5 times more luminous than the Milky Way, is quite compact. Cool. All right, let's head to the next target. And it is Lambda Cassiopeiae. That won't be a very long slew either. Lambda Cass. So it's right there in the middle of the screen, that star. This must be another naked eye challenge. Let's show the chart on this. Oh, that's the upside down Y. So let's remember that's lambda, L. So why are we looking at this? It's number 111. That's under medium scope challenges. Why is this a medium scope challenge? Harrington writes, the Rayleigh criterion and the Dawes limit were formulated to predict just how close a pair of stars could be resolved, at least partially through a given aperture. Using the formulae discussed in Chapter 1, a 6-inch aperture should be able to discern the duality of a binary star with components separated by 0.91 arc seconds, Rayleigh, and 0.76 arc seconds, Dawes. At the other end of this chapter's aperture range, a 9.25-inch instrument should be able to resolve at least partially pairs of stars separated by 0.59 arc seconds or 0.49 arc seconds, respectively. These are ideal numbers based a pair of 6 magnitude yellow stars. These are ideal numbers. That looks like a typo. In the case of the Dawes limit, these values predict how close those stars can be to each other, but not necessarily resolve separately. Can your telescope meet the Rayleigh and Dawes challenge? Here are 3 pairs of stars that will prove worthy adversaries for the 6 to 9.25-inch telescopes. All lie in fairly close proximity. Let's see how well you do. First up, looking for a tougher game, take aim at Lambda Cassiopeiae for its listing in Otto Struve's catalog. STT12. Lambda's components shine at magnitudes 5.3, 5.6, a little brighter than Dawes' ideal test stars. The resulting glare makes this test all the harder. These 2 blue-white main sequence stars orbit a common center of mass once every 640 years and are separated only by 0.3 arc seconds. I don't see how we'll be able to do that. If you own an 8-inch or larger, Lambda Cass is a formidable opponent. All right. The dare has been cast. The die has been cast. Let's zoom in. So this is the real-time view. Now look how bright it is. Wow. Is that the binary star? Okay, so let's stop using this right here and let's darken that. Huh. Let's stop live stacking and go with 3 seconds at 400 gain. Boy, you know why? It's because that's the best that our pixels can do, because we have such a wide field. Our field is 2 degrees wide. So that's so bright that it's, if that is indeed it, we are failing the test. Yeah, the Orionids are coming tonight, but remember, with the moon, we're probably not going to see them much until the moon sets. So after the moon sets, which is around 12:30, we're more likely to see them. Boy, I'm a little bit saddened by the fact that because we have such a wide field of view on this RASA, we're not able to split this binary, are we? Let's go to the STF 3062. Okay, so I'm going to put an observation here. Bummer. I don't like to fail anything. These stars are so bright, and our field of view is so wide. If we're not mistaken, we failed this test. We could not split this double. Oh, Ray got rid of it by tapping on the video, and now it's gone. Oh, that's cool. Right, you're right, Tiffany, the Orionids, or whatever you call them, they are still going through this night, but like I say, the moon is just going to obliterate them. Let's go to STF 57. We're not live stacking. Music is so loud. You can't hear it. There. You can hear it just a little bit. There, and we heard did you hear the tone? That tone was the tone that you get when it reaches the end of its slew. Let me dial that. Can you hear that outside noise there? That's just noise in the night. Can you hear that? All right, good luck with the Orionids, Fuman Neil. Are you guys able to hear that? Just night noise out of the scope. is quiet. Maybe nobody can hear it. Well, anyway, that's the night noise. We'll start the music again. I'm going to dial the volume down so we don't blast you out. So do you hear that music? Maybe right there. Are you hearing that music? You guys are quiet. Okay, where were we? We're back here at, oh, maybe we can split this one. I bet it's this. Oh, it won't be in deep sky image annotation. We'll have to go look in Stellarium. We're looking for Hipparchus 398. Ray nor Tiffany heard music. I'll turn it up a little bit more. Okay, so let me know if you hear it now. Maybe it gets different volumes at different times too. Okay. That's very loud when it's on. Okay. Back down. All right. Is this it? I don't think so. That maybe? How do we hunt for this? STF 3057. What is search? I'll just go click on F3. STF. Boy, that's an odd star name, isn't it? Stellarium doesn't have STF names. What else could this be called? Hipparchus 398? Hipparchus 398. There, it's got that. Is that it? Yeah. Wow, look how close those are. So if we could split those, here are 4 stars in a bow, like a bow and arrow, and here are 5 stars in a bow, and they open up like a flower petal to this star. And on the other side, oh look, here are 2, 3, like 6 stars in a bow. So all these are aiming at it. Let's go see if we can find that. Boy, our focus looks like it might have dropped out on us, didn't it? Look. I bet that's it. Surely that's it. Right? I don't know where all those bow stars are, but or maybe that's what we're seeing. I'm lost. The last sounded like dishes clinking. Hear the music. Yeah, that's right. They do have some bells or something they play in this. It's almost got to be it right there. All right, let's go to the next one. STF 3062. Oh wait, let's do a quick observation. Oh, switch to full screen gets rid of the emoji. This double was easy. Now let's go to 362. Pretty close by. So what these are, Harrington's give you the chance to try to split doubles. And a lot of people, I mean a lot of astronomers, they get a real big kick out of this, looking up double stars and trying to split them. I think the RASA field of view is just not ideal for this task because it is so wide. You saw we were able to get all of Andromeda Galaxy with M32 and M110. We were able to get the entire galaxy in one field of view. And that's because we have this 2-degree wide, field of view with a RASA. But I think maybe a better setup, a better rig for splitting double stars would be something with a focal length that's a little longer, like 1100 millimeter focal length or 1000 millimeter focal length, because this focal length is essentially half that. And it's good when you want to look at something wide like the Andromeda Galaxy, but it's good until it's not. And this is a task that's not perfect for a RASA because it is such a wide field. So is that the double star I fear? Yeah, now you can kind of tell it's a little oblong, isn't it? Feel how there's a little star right there? I bet that's it. This is STF 3062. Let's go look at the chart on this. But I think it's fun to try this, and that way at least we can see. This is Hipparchus 518. Yeah. I think it's important to try it so we kind of see what the telescope's good at and what it's not. Now here are 3 stars in a row. We might be able to find this that way. Look how this double here is part of like a forked stick to try to find that. And then these 2 stars point at it. Let's see if we can find this. So this might be the forked stick. That's the forked stick. Yeah, see there are those 4 stars in a row. So that is the star right there. Sorry to say. And all we can detect is that it's a little bit oblong. I wonder if we'll dial down our gain. I wonder if we're just like, what do you call that when you're overspilling your photons? That's a gain of 200 at 3 seconds. And that's a gain of 100. Bummer. These are 6th and 7th magnitude with 1.3 arc-second separation. Bummer. We didn't think this, we didn't think we were splitting this binary either. Rats. Ray says his 10-inch diode works well because 1200 millimeter focal length. Exactly. Rats. So we're not good at splitting stars, sadly. That's just, unfortunately, one of the downsides. I'm going to go out here and say on the web, what is this called? The Dawes limit? What is the Dawes limit of a Celestron RASA 11-inch telescope? 0.42 arc seconds. Look at that. And these are 0.42 arc seconds. These are supposed to be 1.3 arc seconds. So this should work, shouldn't it? Do you think it's because we don't have the right camera matched with it? Guess that's possible, isn't it? In other words, if we had a camera with smaller pixel size, then the resolution would be finer. So that's kind of a bummer. Oversampling, that's right, Ray. That's what it's called. Tiffany, I have to break out my 10-inch Dob soon. It's so heavy. Tiffany, we didn't know you had a 10-inch Dob. That's huge. Tiffany, you've been hustling us. You've been holding out on us. You've had a big scope all along. In fact, you're bigger than the medium-sized scope challenge stuff. Boy, she's been all along. She could have been doing this stuff. All right, let's go to object number 147. And you know, you guys are going to go crazy on this one because this has so many different members. What is the deal? 147, it has like, look at all these parts of 147. What are all these things? M33, my goodness. So to find this, let's go to M33, Triangulum Galaxy. And just to get our bearings, it's east, directly east, due east. All right, so now let's go to current object. Now this time I'm going to turn the music down. Everybody listen. I'm going to turn the music down. I'm going to turn the volume up. And we're going to slew. See if you can hear the telescope slewing. Here we go. Ready? Everybody listen really closely. Okay, you heard the tone, I bet, at the end. I wonder if we heard the beginning of it, and I wonder if this is like a auto gain control microphone. So I wonder if it turns it down after we got started. Because once it got started slewing, we didn't hear it much, did we? At least that was my experience on this end. Okay. So here's M33, and you can see a lot of objects. That's what they have us looking at. It's all these objects. Fumani is asking, is there the possibility that the binary are aligned? Stu says, that'll make Doug feel better. Just assume that they're aligned and one of the binaries is eclipsing the other one. I don't know. I think Phil Harrington probably picked two stars that we're not looking at them edge on. We're looking at them top down, so they should always be the same length apart. They just orbit around each other. If Phil Harrington was on his game. Okay, so the first thing we're looking for here is IC132. What do you say we go over here and plate solve? Let's see, we want to just say plate solve only. We're going to have to focus in a minute because the temperature has changed enough that we're out of focus. Oh, I bet we don't have enough stars to plate solve. Let's see, I want to set this on 3 seconds. And a gain of 400. Hope it did. Let's try that again. Plate solve and resync. Yay, Ray heard the start and the stop of the scope. So that's what I think. Ken heard it very faintly too, the start and the stop. And Stu, like a dentist drill. That's it. Very picturesque. Yeah. Tiffany heard it as well. So that adds a little bit. I'll leave that sound on, but I don't think you're going to hear it very often since we have the music running too. So this is M33 and it's a large scope challenge. Probably we're going to have trouble because the temperature has caused us to be out of focus. It was 1.35 degrees off with that big slew that switched meridian sides from Pier West to Pier East. And this is M33. clear. Triangular Galaxy is the third largest member of the local group of galaxies behind the Andromeda Galaxy and the Milky Way. So what Harrington has done here is picked out a galaxy that has a lot of deep sky objects within it. Certainly beautiful, isn't it? That's just 30 seconds. Look at all the blue light. Well, we are out of focus, aren't we? This is not going to go well. So then he has this map. And he points out all the different objects he wants you to log here. So a pretty crazy list of all the different deep sky objects. Let's start with deep sky image annotation on for a second. Cheat. I wonder if we're going to have to plate solve only. To be able to see this. Does the lens fog up with low temperatures and humidity, or does it have a lens warmer? It does. I think the dew chaser, we would be probably toast after 20 minutes or so without those dew chasers. We run a dew chaser on the large aperture of the RASA. We also run another dew chaser on this smaller ASI 178. Can you see that little felt band around the outside of that red camera? So that's the dew chaser for the 178. And then on the RASA, see this little black band here at the end? The little black band up at the top edge, right before you see the dew shield. So we run this huge dew shield and also a dew warmer there, or corrector plate warmer, whatever you want to call it. Okay, now it's a good question, by the way, Ken. Well done. Let's see if this helped us pick up any more objects. Oh, yeah. Let's zoom in now a little bit better. This is kind of cheating, isn't it? But it does save us time. All right, so the first one he asks us to look for is, I guess, these should technically be from the left to the right. That's the way they should move. Starting on the left, he asks us to look at IC132. It's a galaxy. And then IC133. That's an H2 region and a galaxy. Let's turn it off long enough to see these and enjoy them. So there's 132, and there's an H2 region. Boy, our focus is just really bad, isn't it? The other night, we did a focus within SharpCap, didn't we? But I bet you can't do it while you're on a galaxy, right? Stu watched an Astro Biscuit video where he had to use a hairdryer to warm his scope up. Yep. Oh my goodness, JM, thank you so much. You're so kind. We got to go focus this. This is ugly. There's no doubt about it. All right, so let's do this. It's 12:11. Yeah, this is worth it. Let's go back over to Stellarium for a second and pick out a place where there are just some stars. A fairly rich field, like right here maybe. And let's stop live stacking this. And let's slew to that object. Not very big slew. So now we're pointed right here. And there's our screen. Now we can either disconnect the camera here, because that's what we know how to do, isn't it? And let's go into Nina real quick, because I didn't know how to do that the other night. We have electrically heated windows on plane, but would blur a little on your purpose. JM, you rock. I agree, Tiffany. All right, so let's... Where's Nina? Oh, there it is. And we have to hook up the camera here under... Okay, so I found the camera and the focuser. Now you go down to imaging and start autofocus. While we're focusing, in chapter 2, now return to the same scene. Deep sky objects within M33. Actually, if you succeed in meeting small scope challenge 67 by spotting NGC 604, then your study of M33's internals is already underway. We're back again to dig a little deeper. NGC 604 is just one of a dozen or more targets within that distant galaxy that are potentially visible through 10 to 14-inch telescopes. All are listed in table 6.6. NGC 604 is found near the tip of M33's northern spiral arm. So basically he points out each one of these objects. He says some of them just look like a grayish stain. Keeps pointing out where to find these targets in the arms. So are these objects inside of M33? I guess they are, aren't they? They're not like lying on the plane of it on the way, are they? They're literally inside of M33. Sharp cap focus is really slow, Ray says. JM, slew baby slew. We have slew sound now too. Well, good. Nice. You know what I'll do is I'll figure out how to turn that up in the mixer. Let me go down here at the bottom. Is that the mixer? No. Here's the mixer. Open volume mixer. And reflector is the one we want to turn up. Now let's turn the Google Chrome down a little bit. And keep the system sound up for everything else. Now, let's turn up that channel. Oh wow, yeah. That's very effective. See, it's letting me turn up that channel a lot louder. Stu says, could just be Doug humming to trick us. Now you guys have to tell me when this music gets so loud that it's obnoxious. Because right now it's not turned up enough. So what, maybe right there? So can you hear the music now? Otherwise, what we have now is the scope sound through that security camera is going to be turned up double as loud as the music is. And next time it slews, we should be able to hear it over the music, I hope. But you guys have to tell me what that music sounds like. I wonder if I can turn it up in my... Let's turn the Google Chrome down a little bit. Good luck, Fumani, seeing the Orions. You're very kind, Fumani. He says, always a pleasure to meet such a great community and a wonderful stream, Hill Sky. Thanks a lot. Make my heart smile. Luck and night off. Good night, Fumani. Good luck with the Orionids. Okay, so you can see what's happening here. I think if you've been on the channel before, by now you've seen, but if you've just, maybe you're watching the recording. By the way, thanks for watching. And if you are watching, if you like content like this, give it a thumbs up, please. Hit like. And we invite you to subscribe, by the way, so that you can be notified next time we do a stream like this. But if you're new to the channel, you can see what's happening. The focuser is moving off one step at a time, experimenting in one direction to see how small it can make the pinpoint of the stars. And as you can see, it wasn't having very good luck. It got off the edge and it realized I can't get them smaller if going in this direction. And now it's going in the other direction and it's trying to make them smaller. There you see it just bottomed out and now it's starting to climb just a little bit going in the other direction. So again, the pinpoints of light are getting a little bit larger now going off in the other direction. And it automates this totally on its own. It takes like a 10-second exposure and then it plots the size of the stars. Then it takes another 10-second exposure, plots them again, and averages between the two, or takes the larger one, I can't remember. And then it plots those on this graph. And as you can see, it has already found the best focus for us, but it's just going to check a couple of other positions. And once it reaches the point that it realizes, oh, okay, there's no sense going any farther, then this automatic routine is going to stop and say, I've now pushed the focus motor back to the place where I was able to get the stars as small as possible in pinpoint focus. Does that by looking at the half radius luminosity, the luminosity of the pinpoints of stars. And you can't really be on something like a galaxy. That's why we had to move it off of the galaxy because that would just mess it up. To see all those gaseous clouds and stuff, it just could not compute that because it would see the whole thing as one big star, so to speak. And you have to move it off to see a lot of points of light. And in NINA, we're using the one where it's using multiple points, like it might be looking at 200 stars. And what you want to see is this hyperbola, this hyperbolic, whatever you call this curve, parabola. And when it's done, look at this little red dot. It's going to move the focus motor back to this red dot and say, Doug, Emerald Hill Skies and community, you're good to go. Don, good to have you stop by. Nice of you to hit the like button. Bless you, Don. So you're saying, well, how will you know when it's done? Well, it's because this little red stripe down here will change to a message that says start again. Right now, since it's still on X, it means that the routine is still running. And you do need to let it run all the way through, because at the end of trying to focus up here, it has to decide, okay, let me run the focus motor back to this red dot middle. And once it does that, then and only then are you good to go. This is a beautiful hyperbola, hyperbolic curve, parabola, whatever you call it. It's a beautiful routine. Thanks to Joko, what's his name, for writing this, for the people at NINA for making this available to us. It's amazing. So now it's done. It says start autofocus again. And it put the autofocus, put the motor, the focus motor back here where this red dot is. So now we'll go up here under equipment and we'll disconnect the focuser and disconnect the camera, because you can't have them connected to more than one thing at once, in my system anyway. And then we're going to go back to SharpCap and connect the camera again. Now we're going to go back here and we're going to say, please go back to M33, not me, M33. And current object slew back to it. Iceland volcano stream. You guys have been visiting another channel, huh? Okay, back here in SharpCap, we're going to assume that we're on track. We're going to assume that M33 is in the middle, because we didn't go very far, so surely it didn't lose. I'm going to clear that last stack. Surely it didn't lose its, what do you call that, like orientation? With slews that low, that small. Okay, we're back. Much tighter focus now. Now we have is just the grain of a new image. Oh, Don, you've done a annular solar eclipse. Cool. All right, so let's start looking at these galaxies. And while we're doing it, we'll do a plate solve only. That way, we'll be ready to use deep sky image annotation. But basically, we start over here with IC132 on the left. It's a beautiful galaxy, isn't it? IC132 is up here. So it's above the fray, up above a bright star. There's a double there. There's IC132. We could see it without plate solving. Much better focus now. So there's that smudge for IC132. And it is an emission nebula, 42 arc seconds wide. IC132, emission nebula, just 42 arc seconds. Good night, Ray. Oh, you're saying good night to Don, sorry. Arc seconds wide. And then 133 is along a line of objects to the right of it, right here, along that line. So it must be this. Let's turn our deep sky image annotation to confirm. Yeah. So it's an H2, a hydrogen alpha region here. It stands out, doesn't it? H2 region stood out to us. It looks like a, it sort of looks like a cluster though, doesn't it? Rather than just a cloud, right? It's like an odd cluster. Calls it an emission nebula. It's just 24 arc seconds wide. Who knew there were this many things inside of M33? You guys probably did. I didn't. Okay, the next object is NGC 588, and that's up here at the top. Again, it's above the fray. There's the core. Should be centered halfway out to this bright star. So here's the core. There's the core, there's the bright star. How do we see that? Should be right there in the middle. This is supposed to be an emission nebula. How would you see a nebula? Let's make the sky a little darker. I'm going to hold my shift key down and move this black level bar a little to the right. Trying to make the sky a little blacker. Don, thanks for the encouragement, brother. It says very nice. So is it this? I bet it's this. (588) is 40 arc seconds wide. Boy, I would have just thought that's like I would have called that a star birthing region, and I wouldn't have even thought of naming it. NGC 588 would have just looked like another star nursery to us. But we could make out the H2 region, or the emission nebula, and a cluster of new blue stars, oblong in shape. And then IC131 is halfway between IC133 and 588, only closer to the core. So halfway between these, but closer to the core. So right here. That's IC131. Emission nebula, 6 arc seconds wide. Oh, that's small. So maybe it's this. Let's check with deep sky image annotation. It's so small, it's not even plotted in deep sky image annotation in SharpCam. It's not even listed. It's an unlisted number. But we did have 137 here. (131) is not listed. Look at this arm that swings real wide out here. It's like way wide, isn't it? (588), 131. Here we go. We were looking too tight. So there's 131 right there. Yeah. There's even, I bet there's even a hint of red in that, isn't there? You guys that are not colorblind? I bet there's a hint of orangey red. Tiffany, I bet you're not colorblind, are you? So that is IC131 with a hint of red. Teeny. 42, oh my goodness, 6 arc seconds. The next one is NGC 592. 592. Oh, there it is. Association of stars. Stellar association. And emission nebula, 21 arc seconds. NGC 592. Remember that is right here. That actually stands out, doesn't it? This stellar association and emission nebula really stood out. Maybe because the sky is so black behind it. It actually stands out better because the galaxy isn't as strong behind it, right? So when you see that, you say, oh yeah. That's at 278%, but look at that stellar association there. And then we're supposed to look at 595. This has been up for 7 minutes now. And it's really looking pretty, isn't it? Here's 595, H2 ionized region. Right here. .30 arc seconds. Beautiful H2 region. And then 142, 143. I see 142 and 143. Down here, more hydrogen. 142 and 143. These are backlit. So 142 is there. 143 is there. You know, I wouldn't have noticed all this red. .42, 143. The other thing is, with a monochrome camera, these wouldn't stand out as much to us because we're detecting them more because, I think more than anything, because of the color. And I think that's another, what would you call it, like advantage of electronically assisted astronomy, because you don't see these colors when you're just using visual. It's too faint. Everything's just a shade of, you know, starlight and gray, really. If you've done visual observing through an eyepiece, you don't see these little reds and such. 137 and 139 are over here. Now these might show up because they're associations of stars. 137, 139. Where's 140? Not seeing it. $137, $139, but not $140. Let's go back to Stellarium. $137, $139. I see $140. Oh, it's right here. No, that's 142. It's hard to pick out because the artwork, isn't it? I don't see 140. 137, 139, we sure can see. Let's go to his chart, Phil Harrington's chart. 137. Like a little star cluster. 139. Like an open cluster. Ah, it's down on the lower side. 139 is right there.